Okay, for people joining this live stream, we are looking at some incremental language development for Wolfram language, and we have an assortment of topics today, as usual. All right, symmetric difference.
Yes, so this is something we discussed in a recent meeting, and we decided that we had to look at the possibilities because there are several possibilities here. So we can perhaps start by at the end section where I propose because this is just examples and examples. So the main idea here is that there are two functions that we want to explore. So symmetric difference and all complements, they are related. And there are several definitions of how to compute symmetric differences.
Okay,
yeah, let's start here. So for example, all complements will take the complement of each set by the other ones.
By all other ones, by the union of the other ones.
By the union of the other ones, yes. So the fundamental idea here is you have several sets and you want to understand quickly what is in each one that is not in the other ones. Some sort of differentiator.
Well, it's the unique elements.
Right. It could be called unique elements, right? That would be an equivalent name.
Right.
I think that's a less obscure name, I have to say.
Yeah, it's just very similar to what just extending complements to,
complements or complement?
Complement, yeah, complement. It's giving the complement between like an outer product of complement.
Which do you say is more intuitive, the unique elements?
I think unique elements is more intuitive.
I agree with that.
Yeah, I think so too. I was just justifying how I arrived at it. It was natural, but unique elements is better.
So
the problem here is that the function that is usually defined is this symmetric difference will take finally a union. And for example, we have already region symmetric difference, which is all the points that are in one of the sets, actually in an odd number of sets.
That's weird.
It's weird, but it's a logical definition that follows from associativity. So if you start from the two arguments functions, and then you request that the multi-argument function is associative, you end up with that definition.
Okay, so why has this got a list of lists inside it? Because that's obviously different from complement.
Yes, and I see two reasons. Actually, this function, as Bob implemented it, also accepts the var arg notation, but I think it has to be one or the other because otherwise
there's no idea.
The singleton case is ambiguous. And there is a natural generalization of this function, which I was considering while analyzing it, which is what happens if you want the complements by unions of two other elements or three, etc.
Well, I mean, to me,
I think it's nice to have it in a list because you get back a list.
Well, I see that.
As opposed to having var args.
Yeah, I get it. But I mean, I'm trying to think, what is the real use of this? So this is saying unique elements.
I use this a lot. So the general scenario is that I have been computing a list, a long list, by two methods, and I want to check that they are the same. And usually they are not, but I want to know what are the differences. So I have to always do two complements. And this function would give me directly the list of the ones in the first.
Where it's n equals 2, so to speak, where it's just two sublists in there.
Right.
Or imagine going through, your credit card statements for a year and you want to find the things that you only bought once. Right.
Yes.
I only bought plane tickets to Florida.
For some reason, it's you only live once, you only bought once.
Right.
Right. Never mind. Well, okay. Unique elements. That's the proposed name.
Yeah, and personally, I like it more with a single argument as opposed to varargs, but I'm willing to be convinced otherwise.
I agree that I think we should not document the varargs form. Yeah, and whether we have it or not is a different issue. Okay, so now this seems useful. Now symmetric difference.
Right.
If I can ever wrap my brain around what the heck symmetric difference actually is.
So go to the beginning of this section. So the fundamental definition is just that, the first line.
Gosh.
And
Tell me what it is. Okay. Elements that do not appear in both sets. Okay.
Right.
Appear in all sets. Okay, that's the next one.
So think in terms of Venn diagrams. So,
okay, so this one here, this one symmetric difference is the unique elements function. Is that correct?
No. So the thing is that this symmetric difference with two arguments can be generalized in multiple ways. And so I'm discussing here 3 of them. And that was the thing that confused us the previous time. Which one do we choose?
Mm-hmm.
So I'm showing here that there are multiple generalizations. And the one that is typically used, it is in both in the definition in Wikipedia, for example, and in our region symmetric difference, is what I call here associative symmetric difference, whose fundamental definition is the 4th line.
Okay.
So
I mean, I understand this is the analog of our region symmetric difference. I just don't believe people are going to use this in programs very much. I mean, when did you last need to use this? I can't wrap my brain around what this is supposed to be doing well enough to even imagine using it.
The truth is that the one I would certainly use is the other one, the one that still keeps the origin of where the given elements.
Which is the unique elements thing you
Yes.
just defined. Yes, I agree. That one is useful. That's why I was agreeing to it.
Yes, but this is the corresponding function to the one that is usually used in maths.
I understand, but this is, look, if all you have is a set theory hammer, everything has to be a set.
Right, yeah.
And that's what this is doing.
Mm-hmm.
I think we should leave this in the function repository and not build it into the system.
Okay. Now, the one that is in the function repository is the first definition, which I called the global generalization. It simply changes the both to all.
Okay, well, we can put some of these other ones in the function repository as well.
Right, yeah, that's true.
I mean, it's one of these things we could review it again in a year or two, but I just don't see it right now. It just seems like one of these things where it's so hard to remember the definition. It's not a hard function to write. Mm-hmm. Unique elements seems like much more of a concept that you would want. Like, I would think every time I thought about this function, I was going to have to look up its definition, and that's not a good reason to have it as a named function.
Can you click on that link to the Wikipedia? Because I think looking at the Venn diagrams, it's very helpful to understand this one. So it's you are computing these red regions.
Yeah, I understand. Whatever. I mean, why would I care?
I understand.
Irwin is asking, why is one symmetric difference different from all complements? The reason is that in unique elements, which is the rename of all complements, is it's telling you which list each unique element was from, whereas the other one is the flatten of this, or some kind of union flatten of that. It's just telling you which elements are unique anywhere, as opposed to where they are unique.
Right. Now, the only thing I would say, a potential additional argument in unique elements is this idea of, right now we are saying, give me the elements that are in this set, but in none in the other ones. So it could be something like, it's in this one, but not in pairs of the other ones, for example, something like that.
I understand. I can also imagine a unique elements by.
Mm-hmm. True.
You know, there's a certain argument. If there is a well-defined mathematical definition of symmetric difference, we should just have it. And if it's this crazy thing with counting even odds, we should just have it. Because for people who understand it, they can use it.
Yeah, it's the sort of thing that name can only mean that. So for somebody who
Right, then let's have it. And have it mean this crazy even odd rule. Just like region symmetric difference means that, right? So
Exactly.
it's compatible with that.
Yes. And it's var arc. Region symmetric difference is var arc. So I think this should be 2.
Yes. Fine. Let's do it.
Mm-hmm.
Sandra is asking, did we discuss a complement that takes multiplicity into account? We didn't. What do we have to say about that?
I'm not sure what that is. That about multiset theory rather than set theory?
I guess. I mean, so yes, I guess so. I mean, so we're talking about a complement where the universal set, where basically what you're doing is, I would imagine, you've got a list and you're removing from that list things that occur. So let's call it
You're basically indexing the elements and removing the ones with the same indices.
I'm not sure what indices come into it, but I mean, in this case, what
Well,
I would
think of that as A1 and A2
Oh, I see what you're saying.
in the first set and A1 in the second set. So A2,
we have multi-set complement in the function repository. We have multi-set complement in the function repository that does this.
Yeah.
Right. I mean, what this is doing is deleting elements from one list. I mean, really, I would see this not so much. This is a list difference effectively.
Yeah.
This is just subtract elements. I mean, I agree that this is quite useful, especially in some kind of folded form. I mean, I think it's utterly obscure. If we call it multiset complement, nobody will ever know what it does. The question is here, how do you do? Well, okay, so the way you would do this, you would say delete cases. No, you couldn't even do that. How would you do this? How would you do this? How would you remove just the 2-argument form, right? How would you remove just those elements once?
Do you mean what's implementation? What's the efficient implementation of this function?
Yeah, what's a reasonable implementation of that function?
I think it would have to be something that has counters, like some sort of hash table that keeps counters.
Right, but right now, that's not something. If I want to remove, I bet I've needed to do that a zillion times. Remove elements from a list. You know what I'm saying? So that's like delete cases, but it's kind of like delete list. You get what I'm saying?
Yep.
And I mean, you don't really need the I mean, you can sort of generalize it up by having that second thing be patterns. But I think that makes it more obscure. But you don't really need a Verarg's form of this because you can just flatten, you can just, join all those things together, so to speak.
It's not hard to do with a tallying.
It's not super easy to do either.
No.
Right. Yeah.
It's kind of a nuisance.
And another important thing here would be to keep order, which is another.
Yeah, I agree. And you can always get rid of the kept order by doing a sort. this is a good function. This is something, as I say, I'm sure I've used it a lot of times. Sandra is asking about complement counts. What is this now? So this is saying, oh, that's this function we just defined. Right. That's this.
Mm-hmm.
Which one is deleted first? Who cares if they're identical? I mean, if they aren't patterns. Okay, what's the right name for this? So possible name. Complement. What is this? It's like delete cases, but it doesn't have a pattern.
It could be multiset complement.
You gotta be kidding me.
No, not kidding.
I don't know what a multiset is. I mean, of course, I do know what a multiset is, but that is a, that's like you are a set theorist, you're a mathematician, but this is not for mathematicians. This is for people who just have a list and they want to get rid of elements in the list. In other words, this second list, let's give an example. You're processing something or other. Let's see.
Does it remove the first instance or the last instance?
It doesn't matter if it's literals.
Well,
It's going to matter if it's patterns.
The result will make a difference if you want to maintain order.
Right, the order of the result.
I think it should keep the later ones.
Yeah, me too.
Yes, I agree. Right. Yeah, I thought about list delete. The problem with that is, okay, so delete, rather, delete is the analog of insert.
Right, it's positional.
Right. I mean, it's sort of like
delete first case.
No way. No, it's not, because delete case is a pattern.
Right.
Drop sublist. No, because drop is always positional.
Complementary cases.
No, because it's not a cases.
Oh yeah, because
I mean, honestly, to me, this goes with delete duplicates. Right? Isn't it like delete elements, which is the analog of delete duplicates?
Certainly related.
And one could imagine that delete elements has something where we give the elements, we give the thing and the elements to delete. And then we could even have an argument. I mean, so for example, here, okay, so this argument could be n. How many times to delete? Up to how many times can you delete each of these elements? Maybe that's crazy.
I mean, no, you'd rather just have them multiple times in the second argument too.
Well, except for infinity.
Right.
But the case of infinity there,
I would rather have the third argument be something like left.
No, but wait a
right.
minute. The case of infinity is a delete cases, is a fold of delete cases. Right?
It's just delete cases. With
No, it isn't.
alternatives. With alternatives.
Yeah, with alternatives, right.
Yeah. I'd rather have the third argument be like left or right or something that kind of takes
I see what you're
direction.
saying.
Not
Oh,
a
hold
level
on.
spec. That seems like it should be a level spec to me.
Delete duplicates doesn't have a level spec. Oh, look at that. That's whether they should be considered duplicates. It takes a test.
Which is different than delete duplicates by. How?
I mean, I think this should be just the same test option.
Instead of thinking it as deleting,
It's applied
I
to the
wanna
pair instead of the
consider it as
individual.
retain excess elements. Because the second list, it's, well,
It depends how big the second list is relative to the first list. If the second list is 2 elements and the first list is 1,000,000 elements.
right.
Okay, so I agree that if there was any sameness thing, it should be a same test option in delete elements. Well, I'm saying
Why do you want a same test? To handle what?
to decide whether, as you scan this list, is the element that you've given here the same as the element you've given here? So, for example, if I said here, let's say I say A of X, C of Y, etc., and here I say A of blank, comma, B, for example, then what this means is scan from the left of these elements and delete whatever matches that pattern, whatever. I mean, it has a certain delete first character to it, because it is deleting just the first instance of each of these things.
Right. Delete first instances.
That seems to
Plural.
suggest that it's just going to delete the first and be done with it.
Well, first.
Well, it's going to use things
plural.
up according to what's provided in the second argument.
I mean, it reminds me of first case, first position.
Yeah, but it isn't really. It's not. Delete elements does seem like the right name because it's very similar to delete duplicates.
Delete first elements, plural, I think makes it clear that you're deleting perhaps several.
I prefer delete elements. Just there are many
Yeah, I
of our
agree.
functions that start from the left, and it's not hardwired in the name.
No, I agree. Right. Obviously, multiplicities. Sandra's suggesting multiplicities arrow elements as the second argument. Oh, I see what you're saying. That's a cute idea. That's a cute idea, like the way we do weightings, that you can say something like 2 arrow AC, which means delete 2 of A and C. Or presumably something like 3-2 arrow AC. That's a cute idea. Does that make sense to people?
Well, the first one I would interpret as remove 2 pairs, not remove 2 A's and 2 C's.
What do you mean remove 2 pairs? What do you mean? What?
Yes, I would expect that the 2 goes to list AC means look for 2 pairs in the list AC and remove them. Not 2 A's and 2 C's separately.
Oh, you mean a total of 2 things?
Well, not the total. There is no reason why the A, B, C couldn't be pairs. And then you have to be able to specify, I want to remove a pair.
I understand. If they're pairs, wait a minute, is this a sequence thing here or what you're proposing?
No, just changing the first argument, a B, to a pair A, C. Can you remove that, or can, yes, just change that to a pair, A, C.
Oh, fine.
Right, so that 2 A, C means remove 2 A's and 2 C's, or twice the pair A, C.
No, it's definitely not twice the pair A, C. If you just wanted to do a delete, oh, I see what you're saying. You're saying, how do I delete just one element? In other words, as a courtesy, I could say delete elements of A, B, C, D, comma, C. And that would just delete the C, which is the same as complement, except complement doesn't keep the order.
I don't think we can apply that courtesy in the case where the elements are lists.
Right, but with the rule notation, I would expect that 2 goes to A means removes twice A.
That's what I was meaning. 2
Right,
goes
so,
to A means remove A twice.
Exactly. So now if we say 2 goes to list something, I would expect that A has.
Okay, all right. I understand your point. I understand your point. If you have the list 3.2 goes to whatever, then that's a different story. But
right.
One issue here is how does complement? So I think this was what Sander was asking earlier. Complement not changing the order, right? So delete duplicates was added because union changes the order partly. I mean, it's correct that union changes the order because it's treating the list like a set.
Do you mean delete cases?
No, I mean delete duplicates was added to union.
Oh, yes,
delete
yes,
duplicates is the same as union, except it doesn't change the order.
Yeah, sorry.
Right. So now the question is, what is the analog of complement that doesn't change the order? Because that's what we're talking about here, I think, in the one argument. Well, I mean, this is okay. Delete duplicates is to union as this function is to complement. Is that a true statement?
Well, I think my confusion is that delete union can take one argument or several arguments. And delete duplicate can only take one.
I'm sorry, which is union? Oh, okay. I'm talking about the one argument form of union.
Right.
Okay, and I'm claiming that this function, like complement, can take as varargs also.
Yes, but complement of one argument doesn't make sense. I mean,
no, complement of two arguments, which is, I mean, this function, which preserves order, is really not that relevant in the varargs case.
Right, but I think my point is that the proper relation of complement with two arguments is union with two arguments, which has no analog in delete duplicates.
Okay, but I don't think that's relevant. I think what we're saying is that the question is, how would I make a complement that preserves order? Right? And the answer is this function will be such a function. Delete elements is complement preserving order, but only in the two argument case.
Mm-hmm.
Except it also maintains multiplicity.
So
you have to say infinity goes to.
Wait a minute. Wait. Delete duplicates, obviously by its nature, does not maintain multiplicity, right? Because it makes only one of everything, right? So this is, I agree, this is again a little different because it is maintaining.
This is different than the two argument complements in two ways. One, it maintains order, and two, it maintains multiplicity.
Right. So to prevent it maintaining multiplicity, that's what we're talking about. These, thing, arrow, whatever.
Right. So it could be infinity, and then it would be just like two argument complements, but maintaining order.
Steve is pointing out that if there was telemetry on all our functions, it would be interesting to see what's used, what the latest used function, least used function is, et cetera, et cetera, et cetera. Yes. I mean, look, there's a trade-off. In version 0.9 of Mathematica back in 1987, we had such telemetry. And it was frustrating because it was, we got a fair amount of data. We didn't really know what to do with it. There were all kinds of privacy issues. And it's like, we weren't that excited about it. I mean, for example, in the cloud, the server does know, although we don't, largely for privacy reasons, we don't even collect aggregated data on that, although we certainly could. Yes, I agree. It would be interesting to know that stuff. I mean, we have some proxies, like the number of times documentation pages are looked at and stuff like this. Sandra is, by the way, commenting that our single symbol form can't possibly work, and I think I agree with that. I mean, we could make I see. I mean, as a courtesy, we could make the single symbol thing work, but I think it's kind of crazy.
Only for non-list elements, which would be confusing.
What do you mean non-list elements? You mean things which aren't lists?
Yes.
Yeah, I mean, things which aren't lists. I don't know how confusing that would be. I mean, we have other cases of that.
Right. If you're just used to the single form because you've used it with all sorts of expressions, and then you try to do it with a list and it doesn't work, only in the case of lists, it's a little weird.
Yeah, I wouldn't do that. We have already delete cases to do that.
Well, wait a minute. Delete cases deletes all of them, right? It doesn't just delete one of them.
Right. Yeah. But yeah, I would still require having a list around it.
I think that's the only thing we should document, for sure.
Yes. Yeah, Steve is commenting that knowing more about how functions were used would support design decisions. I agree with you up to a point. I think it's one of these cases where it's like A/B testing for websites. By the time it's down to A/B testing, yep, you can do it. If you say, should my website, how should my website be designed? Let's just test it. It's like, good luck. The space is much too big to test. And I think by the time we are deploying, by the time we're sort of A/B testing language designs, that's completely unfair to users because like you're going to write code and it's going to be in one form or the other. And that's like super confusing. But I agree, it would be nice to know, we do have some popularity measures because we know code that's out there in the world. We know how frequent functions are in that code that's out there in the world. And we have that data. It's in Wolfram language data. So that's not a terrible proxy. An example of something we'd really like to know right now is, which we realize we have almost no data on, is what kind of typing mistakes do people make, or what kind of mistakes do people make before they ever get their function into the system? What kinds of input errors do they make? We'd really like to know that because it informs our code assistance mechanisms. All right, I think we got a good new function. This delete elements thing I think is a very useful new function. And we'll have delete elements, unique elements, and symmetric difference. That's a big pile of functions for this short amount of time. All right, should we move on?
Sorry, can we compare a bit in unique elements with delete elements? One is one arc, the other is not. Is that okay? Delete elements still can take any number of lists, right?
I wasn't thinking that way. I was thinking it's just two lists.
I see.
I would start with just two lists and see what happens. The design does not foreclose us on larger numbers. Now, the only thing I don't think we have defined is a single number, arrow, a list. What does it mean? Well, remember, we don't support anything other than a list of elements in the second element there. So that means the only question is, does that mean 2 in aggregate from that list? Or does that mean 2 arrow AC? The 2 in aggregate is not something we can get any other way.
Exactly. Unless you had a max items option.
Yeah.
And do we support a list of rules? Just in case we want 2a and 3c?
No, it's ambiguous. The only way we can do this, the only reason we can do this is because it's the same as with a bunch of other functions. The outermost level of that second argument is either a rule or a list. If it is a list as the outermost element, then nothing inside it is elements to delete.
Right. Okay. So if we want different numbers, we put a list also in the first argument of rule.
I think so.
Mhm.
But the only question is, with 2, is it aggregate 2? I think we're saying yes, because that's additional functionality.
So
Right.
you could
Sander is
move-
commenting that an analogy with the weights to random choice, it should always be a list. But that's the whole point. It's not precisely, yes, that was the pattern that I was using in thinking about this design. Go ahead, you were going to say something, Jose.
I'm sorry, I just forgot.
Okay, no problem. All right, should we go on?
Yep.
Okay, symbols.
Yeah, so this time the various functions are grouped.
Oh,
by
this is, by
symbol.
the way, exactly supporting Steve's comments, because we actually have popularity ranks here. But go ahead.
Out of
What-
about 2,000 to give some
Okay.
sort of scale.
Okay. What is this? This is handling of symbols. Is that what you're saying here?
Yes, so this time the symbols are grouped into some sort of categories.
No, but yes, I understand. But meta, this
Yeah, this
thing,
is
this
meta
first
programming.
category, no, this first category is symbols about symbols.
Exactly.
Right?
Yeah.
Okay. That's cool. I didn't know we even had that. How does that possibly work?
It's only in the current session as implemented. You can do this with a front end token.
I see. So, I mean, to me, we were just talking about this a day or two ago in the context of code assistance, which, by the way, is a meeting that we should probably live stream. Note for the next time, let's discuss doing that.
Yeah, I got it.
Oh. I mean, some aspects of it were, well, quite boring, but not this time, but they have been in the past, so they've not been appropriate. Although actually they've been interesting if you're interested in UX design. Not so interesting from a language design point of view, although becoming more so now. Okay. But what we discussed there is general syntax templates. This needs a discussion with, I assume there's nobody from the front end team here to talk about this one. I mean, this whole question about how you add auto-completions just seems like a thing we should be able to do in general. And I don't even know what this does, where it adds the auto-completion, etc. For each of the argi. Well, I'm a little confused by this. Can we get somebody from the front end team here to not today, but another time to address this? Okay, gutunbound symbols. The heck is that? Oh, I see. Okay, I mean these are somewhat useful, but I'm just I don't know. about this one. This one. I mean, let's just do a little bit of triage of ones that really jump out at us as useful. I don't know why these aren't. I see. This is find all symbols with a particular option. Yeah, I mean, that's kind of obscure. Possible name queue is more like a syntax queue question, isn't it?
And it's basically just name queue, but the symbol doesn't have to exist yet.
Where is this useful?
Just like, for example, in the resource function code, it tests that your resource function name should also be a valid symbol name.
I see. Seems specialized to me. All right, let's just go in and see what
all of these are for the hardcore developer, the ones
right
in that first section.
Yeah, this one is interesting. Ethan is saying we should add an unsupported in cloud to the function repository. Good point. Good point. I wonder whether this one works in the cloud. Does it?
Probably not.
Well, but how do we not know that, so to speak?
It's a good point. We should at least have a way for the author to declare it and then show it on the page, even if we're not verifying everyone.
I mean, let's see whether that one just blows itself to pieces. Splaff. That would be a category. I don't know whether QA tests function repository functions in the cloud. Do they?
I don't think so.
They probably should.
Doubt it.
I mean, like, for example, if I do cloud evaluate of this.
I'm sure it'll be the exact same. I mean, yeah. You couldn't imagine that would do anything helpful anyway.
No, I understand that.
Right.
But that would at least tell you, okay, so this is the thing to bring up with QA. This is for Addison, I guess, to bring up with QA.
Noted.
Okay. This is certainly something I've needed from time to time. This, it's very interesting. Its rank is not spectacular because we've considered until like many times over the last 35 years. Okay, Steve is saying function popularity against last revision date. Yeah, I mean, there's a question of how quickly should we rev something. By the way, I don't think our text recognizes complaining that OCR is kind of old. I think our OCR thing has been revised fairly recently and it's pretty state of the art, if I remember correctly. I think it was revised in maybe a version ago. Let's take a look. We can. Updated in 2020. There's something wrong with it. It's not through lack of attention. EMC is commenting that obviously Wolfram language functions have large automated test suites. Absolutely they do. The problem is we have not been testing the function repository as carefully as we've been testing internal code, because the tests here are these functions are not signed up to be no corner cases. they're signed up to, you've got the source code. If you don't like it, go look at the source code, go modify it type thing. It's kind of the usual story of sort of open source code type things, as opposed to, it's really guaranteed to work and continue working. But yes, it's an oversight probably on our part that we are incorrectly assuming that certain functions, because our underlying functions work. Well, okay, so the real correct thing to do is to ask the question from Wolfram language data, is any of the functions in the implementation of this function cloud, do they have a problem in the cloud? If none of the functions in the implementation have a problem in the cloud, yeah, we could test in the cloud, but it's just for amusement value.
Right. And that was a good example. Those 3 lines of code, but one of them was an undocumented front-end function. Right. So even if we were running against a list of things that we know don't work in cloud, it wouldn't flag it. So we would have to run it against a whitelist of things that we do know work in cloud to even have a suspicion.
Well, right. So this one here, well, no, I mean, this would be, there is a function here. There's a good example. There is a function here that is not in our whitelist of things that are thought to work in the cloud.
Right. But yeah, we wouldn't be maintaining a blacklist. We'd be maintaining a whitelist, which
we have.
is
I mean,
a different thing.
And I mean, it's worth remembering that's not just does it work in the cloud. It's like, can it be in a scheduled task?
Right.
Can it be done with remote evaluate? Does it require a camera? Does it, there's a lot of difficulty.
A lot of those compatibility things are going to be expanded out with Packlet repository, and then it'll work its way back into other repositories as well.
Perkinji observes that a project should naturally translate itself to open source or perish. We've been alive for 35 years, so I think we're okay. And we seem to have a pretty good model. And for many years, much of our code was open and nobody cared. So we stopped. And there are many reasons, some of which will not be obvious to you, why it would be a bad idea. Plus, also, I think people are realizing that the whole, it's just open, it's all free, is always bullshit. Because in the end, if somebody's doing real work, somebody's going to end up paying for it. And the only question is, are the people who are getting benefit paying for it, or is somebody else paying for it? And the people who think they're getting benefit are actually, some weird thing is happening. But we could give a long exposition of that. But we're always interested in, who knows what the future of these things will be. We are experimenting with many different code licensing models. Like our compiled code will have all kinds of different kinds of openness characteristics, which I am not hopeful will lead to any contributions. It's sort of interesting, though, the model that we've had, which we started 35 years ago, our model has survived, whereas many other models have crashed and burned in the intervening years. So that's a thing worth realizing. And has allowed us to continue to be, to innovate and build new stuff for 35 years, which I consider to be not bad, considering that, the total age of the oldest, computers have only been around for 70 years or something. That's a respectable fraction of the total time that computers have been around. So anyway, all right. Well, there's lots more to look at here. I know I'm running into time for the next meeting. What on earth does random string do?
It's trivial.
It's based on an alphabet. You presumably specify an alphabet. Or it's just English.
I think you can specify a character set. Yeah. But I think the default is
randomly choose from a set of characters.
Yeah.
Yeah, well, I've certainly needed this. I mean, this is not useless.
Right. We have
No.
things like random color and all these little random things that are really convenient in lots of places.
Random things that are random, that generate random things.
Yes, exactly.
Yeah, I agree. I mean, I've many times I've wanted a random base pair sequence or something. And obviously I can make it. I just say random choice of that thing and then say string join of it. This is kind of weird. Well, anyway, we should come back again. I'm just curious what some of these other ones are. I don't know why these aren't part of encrypt, these things. This is not something we're going to have a top level. I mean, this is like compatibility with antiquity, so to speak.
Well, could call it classical cipher. And then
why would we want that? Why is it not just part of encrypt? Doesn't it do the same thing that encrypt does, but just in a very lame way?
Possibly.
I mean, in other words, encrypt is taking, you've got a key. So, okay, so I agree that encrypt has a really fancy key in general, or password or something, whereas the Caesar cipher just has a number. Although one could certainly imagine allowing an arbitrary password and you derive a number from that password. Although I have to admit that the thought of a key derivation function for a Caesar cipher is a little bit weird. Yeah, I strongly think these other ciphers should be built into encrypt. For which we probably need at this meeting people who've been involved in like Daria, who've been involved in the implementation of encrypt.
Right. The method option is sort of complicated here. It'd be nice if you could just say method goes to affine. But right now it takes an association with, sub options.
I
thought you could just say a single name if you wanted to. It will default the other stuff.
Well, these mostly have sub option settings, what you'd consider sub option settings, the key string for Vigenère, that kind of thing.
Sorry, which has a? You're talking about Caesar cipher or the encrypt right now?
No, I'm saying if we add these to encrypt, we're still going to want sub option settings for these.
For Caesar ciphers and things.
Sure. Yes.
Yeah, just like we have them for. I mean, these ones here. I mean, I think we got to look at putting. I mean, to me, I don't know whether any of these is an Enigma machine or something, but we probably should have an encrypt that encrypts like an Enigma machine. And the only feature of these is that for encrypt, we don't make it especially easy to get out the encrypted data. Right? I think we can get it out, but it isn't particularly. How do we get this out? Well, if we look at the input form here. Yeah. So, I mean, for example, okay, so here, right, so this would say cipher arrow Caesar. It might have some options. And then instead of a, data would presumably not be a byte array. It would presumably just be a string for the Caesar cipher case.
Yeah.
Sense? And, I don't know whether we can say of data here to get out the data. Hey, that's weird. What on earth happened there? Is that a bug? Hold on. Let's try that again. Okay, I type an open bracket. I type quotes data. No, who knows? Okay, so that indeed pulls out the byte array. So that would be typically what you would actually want to get out in the case of the Caesar cipher, rather than an opaque encrypted object. And I really need to go to another meeting here. Well, good. We 3, terrific new functions that we defined. Lots of other stuff to look at. We really should be, making sure that in these meetings that we are doing some fresh new functions that have come through, and only use as a background task going through the function repository functions. Does that make sense to people?
I didn't understand that.
I'm saying that there's a stream of things that are coming into ILD,
Yeah.
often from me. And I'm saying, let's make sure we decently prioritize those things instead of always going through function repository functions.
Yes. As we commented, we were trying to kind of work through this pile of accumulated pile.
Okay, well, fine. They're not super fast, as we can see.
Yeah.
And the good thing is they already exist in the function repository.
And how do you know
Yes, so
we're
that's the
not
fallback.
prioritizing them?
Say that again?
How do you know we're not prioritizing them?
Prioritizing what?
The things that come from you. That stream. Maybe we just like these more.
Well, okay. Prioritizing as in not prioritizing, but oratizing somehow. This, what on earth is asynchronous dynamic module? Huh. That sounds like a good idea.
It's good.
Well, maybe it should be part of dynamic module.
Yeah, that's why there's that note there, an extension dynamic module.
Sounds like a good thing. Sounds like we need somebody from the front end team here to discuss that.
This would be Lou, I'm pretty sure.
I would think so.
I think he wrote that resource function too, didn't he?
Might have been McClue. Oh no,
Right,
Seward.
I think it was. Now that you mentioned, no. Okay, interesting.
We got a nice potential contribution to the function repository from Don Knuth yesterday, although I think it needs a bit of cleanup. But I think Jose got sent that.
Yes, we are looking into it.
Okay, I better go to my other meeting. Right.
Okay.
Well, thanks, guys. Thank you to folks on the live stream. Good suggestions.